Hi everybody, this is going to be another Unit 3 video over absolute value functions. So first of all, let's just take a look at an example of what the graph actually looks like. I've got a table here of some x values, and we're going to plug it into our function that we're going to be working with, which is just f of x equals the absolute value of x. Okay, so we're going to plug in our x values, get our y values, plot our points, see what it looks like. All right, so if I plug in -3, it's going to become a +3. This will become 2, 1, 0, and then all of these will remain positive. Because remember, absolute value takes all negatives, turns them positive. All positives are going to stay positive. So let's plot these points. Okay, once we plot these points, we're going to go ahead and connect them. And brings me to my first point I want to make here, which is that absolute value functions always make a V-shape. Okay, it should actually come to a sharp point. That turning point is called the vertex, which I have already written above. Okay, so we have a vertex that makes this V shape. Those are important things to know. Now, another important thing to know is that the domain is always going to be all real numbers, and the range is going to depend on the vertex and which direction that V opens up. So in this case, we have a lowest y value. Our lowest y value is 0, so that means that the range has to be all y values such that y is greater than or equal to 0. Right now, another important thing I have at the bottom here, okay? This function that we just looked at, f of x equals the absolute value of x, is the absolute value parent function. It's the most basic version of an absolute value function that you can possibly have. And that's important because we're going to take a look at some transformations. So here are a bunch of transformations. All of the transformations are the red graphs. All of the black graphs that you see, or the black V shapes, are the parent function. Now, I also labeled all of the functions above the graph so that you can see which function corresponds to that red absolute value graph you see below. So here we can see that having that +2 inside of the absolute value bars made it shift left 2 units. But when we have the -2 in the absolute value bar, it made that function shift right 2 units. When we have a +2 outside, it makes it go up 2 units. When we have a -2 outside, it makes it go down 2 units. When we have a 2 in front of our absolute value bar, it makes the line steeper on each side. And when we have a negative in front of that absolute value bar, we have a reflection over the x-axis. Now, I'm very quickly running through these because you have seen all of these transformations in Algebra 1. So it's going to be important to be able to look at an absolute value function and identify what transformations have occurred between the parent function and your function that you have. That's important to know because it's going to help us be able to graph them more quickly and find out some key pieces of information. So let's talk about vertex form of the absolute value function. Okay, the vertex form is what you see right here in this box that I just made. Okay, we have an a value, an h value, and a k value, and all of those are relevant and mean different things for the graph of that function. Okay, the vertex, remember that point at the bottom, or if it's flipped at the top of the V shape, can be found at hk. Okay, well, there's h and there's k. The only thing you have to really be careful about is that sign right there. Okay. If you have a minus sign, then technically you have a positive h value. If that were a plus sign in the middle, that means that you plugged in a negative number for h, which turned it positive. Okay. So you're going to have to really be careful with that negative. The negative that you see is part of the formula, okay, part of the vertex form itself. It's not actually attached to that h value when you're going to find the vertex. Okay, the other important piece here is that a value. And we see here it says that A is going to be the slope of the right side of the vertex for the absolute value function, and negative A is going to be the slope of the left side. So let's actually apply this. Okay, I have a function, okay, 3 times the absolute value of x plus 5. Notice here, I don't have a k value off to the side. Okay, so really you can think of it as being a plus a 0 out here. So we have an a value of 3. Okay, so that means the slope of my right side will be positive 3. The slope of my left side will be negative 3. And we need to use our h and k values to find the vertex. Now, remember, inside it's normally x minus h. So if we have a plus 5, that means that we plugged in a negative 5 for h. So our vertex will be at negative 5, and then k is 0. So this gives us an ordered pair, which is the location of our vertex. So I'm going to go ahead and plot that point right here. Okay, that's the vertex of our V shape. Now, remember, we said the right side should have a slope of 3. So I'm going to start at my vertex. I'm going to go up 3, right 1, up 3, right 1. Okay, and this is the right side of my absolute value function. Now, the left side has a slope of negative 3, so I'm going to go up 3, left 1, up 3, left 1. Okay, and the reason I didn't go down 3, right 1 is because I want it to make a V shape. And if I go down 3, right 1, it's not going to be a V shape, and it's not going to be a function because it would fail the vertical line test. So remember, it always makes the V shape. The negative slope means we're going this way. All right, and there's our graph. So we were able to graph that really quickly without using a calculator, without making a table and generating points. Okay, we can just use the fact that vertex form gives us the vertex very quickly, and that a value gives us the slope of the right and the left side. All right, guys, I hope that this all made sense. Please let me know if you have any questions, and have a wonderful day.